In this video, we're going to talk about some key features of functions and how you can find them on a graph. So by the end of this, you should be able to identify key features of functions from a graph. There's a few vocab words we need to know ahead of time. Some we are probably familiar with, some you may not be. So we have x-intercepts, y-intercepts, solutions, specifically solutions to f of x equals 0. We need to know absolute minimum and absolute maximum. And these we'll kind of touch on throughout the video. All right, so let's take a look at our first graph. It's kind of a squiggly graph here. That's its official name, I'm pretty sure. So let's label all of that vocab on here. So let's start off with the x-intercept. And that is actually the same as solutions to f of x equals 0. Okay, so these two are the same point on the graph. Typically, we would write the x-intercept as an ordered pair, whereas the solutions to f of x equals 0, you're just going to write the value of x. Okay, so that's really just the difference between those two is how you write them. So we have a couple x-intercepts on here. So I see -7. It's called the intercept because it intercepts the x-axis. Right, so we have -7, so the x-intercept would be -7, 0, -4, 0, and 6, 0. Even though that doesn't cross it, it still touches the x-axis, and that point is going to be 6, 0. It like touches it and then comes back up. Okay, next points, let's talk about the y-intercept. And that may also be known as f of 0. So again, these would be the same point. Okay, so let's label those. With a function, there should always only be one y-intercept, right? Because we can't, if we think of that vertical line test, we can't possibly have two y-intercepts because that would not pass the vertical line test. But our y-intercept is up here. It's where it crosses the y-axis, and that is 0, 6. And let's write that. That is the y-intercept. All right. So we've touched on the first three here. Let's talk about absolute minimum and absolute maximum. So the absolute minimum, that is the y value of the lowest point on the graph. So if I look at this graph, the very, very lowest point would be, it looks like right here. Right, if I kind of draw an imaginary line, no other part of the graph goes as low as that point. So this is going to be our absolute minimum. Sometimes we write it ABS, min, absolute minimum. And that value is -2. And lastly, we have the absolute maximum, which is just like it sounds, the y value of the highest point on the graph. All right, and let's see what that looks like on this graph. I know we're getting a little bit messy here. I'm actually going to have to erase y-intercept in order to see it. So if I'm looking at this graph, the very highest point is way up here, kind of like a roller coaster, the highest point of that roller coaster. And again, I'm just going to draw an imaginary line across, and no other part of my graph gets that high, except that it does. Because I just noticed these are arrows over here, right? These arrows keep going and going and going. So there is no absolute maximum to this graph or this function. Let's take a look at what that might look like on this next graph. So we have a nice portion of a quadratic function here. And this one does have endpoints to it. So this will have an absolute maximum. And that absolute maximum is up here. This is our absolute max. And its value is 9. So the absolute maximum of this function is 9. The absolute minimum of this function, the lowest point, is down here. And it looks to be 0. All right, that is handy because our x-intercept is actually also 0, 0. Which also means, since it's the origin, that our y-intercept is 0, 0. So let's write those all down. Our x-intercept was 0, 0. So if instead I phrased that, what are the solutions to f of x equals 0? I would say 0. The y-intercept is 0, 0. The absolute minimum is 0. And the absolute max is 9. All right, and typically we're not going to have them all be the same value. Usually they're going to be different values, kind of like we saw in the previous graph, but this is a case where they all did line up.